Good morning, student. Today we are going to see about the instruction set. In previous class we saw about arithmetic instruction set. Today we see about the logical instruction set. Okay. In logical instruction set we have AND, OR, XOR, CPL, CMA. These are your logical instruction set, and NOT. Okay. So here the NOT, it complements each bit of data to produce one's complement of the specific operand. Okay. So this is your example, and the operand can be a register or memory. That is, AX can be your register or memory. So next is your AND. So in this AND operation, the instruction performs a logical OR, operates between an accumulator or a specific register or a memory location, and stores the result in the accumulator. Okay, AND operation. This instruction performs a logical AND operation between accumulator or a specific register or a specific memory location. For example, AND B. So the value of B is stored so here the example is AND AX, 1240. So the 1240 has been perform AND operation with the value stored in the AX. Okay, next OR. So it performs the OR operation of designation and SRC. Okay, so example is OR AX, BX. The value stored in BX is ORed with the value stored in the AX. So here SRC can be an intermediate number or register or memory location, and DS can be your register or memory location. Both operands cannot be a memory location at the same time. So the CF and OF becomes 0 after the operation, and PF and SF and 0 can be updated. These flags can be updated. So the carry flag and 0 flag will be 0 after the operation. Next is your XOR. It performs the XOR between DS and SRC. SRC can be an immediate number or register or memory location, and DES can be your register location or memory location. So both operands cannot be a memory location at the same time, similar to your OR operation. So here also the carry flag and the auxiliary carry becomes 0 after completion. So parity flag and SF and 0 flag can be updated. So next is your test. It performs the AND operation of between designation DES and SRC. So SRC can be intermediate number, and it can be a register or memory location. Both operand cannot be cannot be in memory location at the same time, where CF and OF become 0 after operation. PF, SF and ZF are updated. So here are the few questions which can be asked. So just try to work out it with the help of example, and if you have any clarification, contact me. Good morning, students. Today we are going to see about a branch control set, instruction set. In previous class we saw about arithmetic and data transfer operation. Today we will see briefly about branch control sets. Okay. So what is branch control? This group contains the instruction for conditional and unconditional calls, subroutines, return and restart. This is said to be your branch control group. So you have two jumps. That is, one is your unconditional jump, another one is your conditional jump. So in your unconditional jump, the instruction JMP, that is said to be your jump. That is here in this example jump, ADR is your address label. Okay, so label is your PC. So here it represents the jump to the instruction specified by the address. So this is said to be your unconditional jump. Okay, here the value is directly moved to the place immediately. Okay, next is your conditional jump. So in your conditional jump, what happened is your jump address label variable JUMP represent your conditional jump instruction. So here the jump instruction specified by the address, if the specified condition is fulfilled, the condition is applied, then it is said to be your then the value has been jumped to the particular place. Okay. For example, if the condition is satisfied, then it reaches the particular memory location. And next, let us see about the branch control instruction set mnemonics, where JZ is a mnemonics. So in this, here it represents jump if the result is 0. So if the result is not 0, the loop will be keep on executing. Next is your J and Z. So it means that jump if the result is not 0. Okay, so until it not 0, the loop will be getting executed. Okay, next is your JC. JC is something that jump if there is a carry. So whenever you get a carry, it will be particularly stored in a particular address. Next is your JNC address. Jump if there is no carry. So JNC is something that mnemonics that jump if there is no carry. Next, let us see about the unconditional call. So here in unconditional call, it represents as call, CALL, and address and label. For example, you can say that call the subroutine identified by the address. This can be represented by the help of this instruction set. Next is your call address. So in this, that call the subroutine identified by the address if the specified condition is fulfilled. So this instruction set is placed wherever the call the subroutine identified by the address that is specified by condition is fulfilled. Okay. Next is your CC. CC is something that call subroutine if carry status is equal to 1. Next is your CNC. CNC is something that calls subroutine if the carry status is equal to 0. Next is your CZ. So here in which call subroutine if the result is 0. This instruction is again used. Next, let us see about stack, IO and machine control group. So here in this IN port address that represent the input to the accumulator from the input output port. So next is your output. Output is something that output from the accumulator to the input output port has been given. Next is your push RP. Push the content of the register pair to the stack. So this one immediately move the content to the next stack. So this is your assessment question. If you have any clarification, kindly approach me. Thank you.